Hey, thanks everybody for coming. So my name is Srini Kadamati, and I am, one second, let me turn on screen sharing. I'm the learning platform team lead for Dataquest. We're an online learning platform for data science. Here's a quick preview of the platform if people are interested. We kind of do everything, the content, the support, you run code on the right, and then we kind of give you feedback as you go through the product. So that's kind of a quick overview of Dataquest and the product that I spend kind of most of my time thinking about. So a quick overview of the talk. I'm going to start a little bit by talking about my own background, which I've grouped in the education section. Then quick overview of the life cycle. So the actual learning process that most people go through for data science, some of the roadblocks that they face, and just some proposals for how that could be done better based on kind of my own experience. Just for some context, I've been involved with Dataquest for about 3 years now. I've helped hundreds of people get jobs, indirectly helped thousands of people think about their career and kind of what to learn and how to help them navigate the different roles that are out there. I'll talk a little bit about the data science landscape. So data scientist is a very broad title, and there's kind of almost probably hundreds of other titles that are more specialized and more helpful in many ways to actually think about framing your own career. Then I'll go over the key principles. So what are the principles that I've seen people adopt and kind of comes from good research literature as well as business school literature in terms of what actually works and what routines, what habits, and what are the key ideas people actually use to get a job or make a career switch in the field that they're in. I'll talk a little bit about the challenges. So what are the actual challenges people face and how can applying some of those principles help with that? I'll go over a few success stories. Most of them are from Dataquest, so I can kind of speak more personally about their story and then just leave lots of time at the end for questions. So a little bit about myself. I went to University of Texas at Austin for undergrad, made these little bar charts just to show the different kind of things that I learned. And you'll notice that I really frame education as a lifelong thing, which is why I included all my other work experience as well. So at UT Austin, I focused on math with a little bit of business. Ironically, the best thing I learned in university was networking, things like productivity. The math theory was helpful, but some of these other kind of life skills ended up being some of the most useful things actually in my own career. I had a summer internship at Bizarre Voice, which is a company based in Austin that does analytics for e-commerce companies. And I spent a lot of time learning about software engineering, and also as one of my first internships, it was a great experience just to learn about how to get work done and how to be productive. I also interned at IBM Watson, which was it was a really fun internship. And I spent a lot of time actually just writing code and reading papers, and it was a good kind of mix of software engineering and data science. I spent an internship and a full-time job at Radius Intelligence, which is a analytics company based in San Francisco that focuses on small and medium business data. The data is very interesting, it's very fragmented, and there's a lot of players in the space. So there's kind of a lot of interesting business problems and technical problems on thinking about how to stand out. So it was a good mix of software engineering and data science. I briefly worked at a startup called Bionic Health, which is no longer around. Basically worked on a predecessor to HealthKit, Apple's HealthKit. And then for the last 3 years, I've been at Dataquest Labs, which is the company I'm still involved with. I started out as an author, so my background was in data science and some software engineering, and I actually wrote a lot of the content for the site. And then I switched to managing a team of people who write content as a director of content. And then I switched over to now the team lead for learning platform, which is engineering and product combined, essentially. So my role has shifted a lot, but it's been exciting to kind of go through the journey of helping students writing educational content, and then now kind of focusing on scaling that up and focusing a little bit more on management. Life cycle. This is a quick overview of the way I think most people think about kind of getting a job, really in any field, but I think this is especially true in data science. The general life cycle is kind of like learning. You kind of learn a lot, right? And I think the school system, university and otherwise also is a good example of this. Learning, you spend a little bit of time practicing, and then you kind of you build a portfolio or you get internships, right? Some kind of proxy for experience and real world knowledge. and you spend some time networking, and then you kind of get a job, right? You start interviewing and you land a job. And so I put these two images here, the cave all the way on the left side, which I think many people think of learning as a very either isolated or kind of a disconnected activity from the rest of industry or kind of the field that you're interested in. And then the interviewing and job phase is kind of this pot of gold at the end of the rainbow that you're kind of just like struggling to get out of the cave. And then, I'm mixing metaphors here, but you get the idea. And I think the challenge is, this is something I've noticed just being involved with Dataquest, helping others think about their careers, is that most people actually drop off in this really beginning early phase. They get stuck trying to figure out what to learn, perhaps getting too bogged down in theory versus application, getting overwhelmed by the number of tools and things that they feel like they have to learn, and also not having proper avenues for practicing and actually getting feedback. And so the really interesting thing, and this is why at Dataquest, this is actually this phase right here in the beginning is where we kind of focus really sharply on, because once people can get past this phase, then the rest of the phases are challenging, but at least you have a good foundation to go on, and you can kind of get past where most people drop off. And so I've actually redesigned this workflow a little bit in the next slide to show what I think it really should be like, and the people I've seen succeed, and a lot of this I've done myself. This is kind of a better process of the actual life cycle. And so it seems chaotic, but I think it really starts with having loops. So you learn a little bit, you practice a little bit, and you build a portfolio. It could be a small project, but you're kind of using this cycle to make sure you're getting feedback. And along the bottom, you'll see networking. So I don't really see networking as this thing you do at the end. Like once you've learned and once you feel like you have the privilege to talk to other people who could help you get a job or think about technical things to geek out about. I really think it has to be something that you have in the background. Maybe it's as simple as going to meet up every week. Maybe it's reading papers or kind of working on technical projects with friends. It doesn't, networking is a pretty broad thing. I really just see it as engaging with others and kind of learning from them and kind of slowly building out a network. The good thing here is that, as you start networking, you also get inputs. You also get inputs into your learning and practice and portfolio loop, right? It's not just, you're not learning in a cave somewhere, you're actually kind of getting feedback from the external world. And when you go to, I've been to these meetups and some of these other events, even virtual events like this one is a great way to get informal and indirect feedback. Is you can people want to help others that are kind of starting the learning journey. It's just something that everyone wants to do. If you're at university, it's even easier to kind of get this kind of feedback. And ultimately, I think that can help refine your trajectory. And in the next slide, I'll talk about why this is important and why the trajectory actually plays a big role in this learning process. But yeah, essentially, you kind of want to have this loop of learning, practicing, building projects. You want to be getting feedback both from networking with others and working on projects with others, but also from interviewing. So I actually encourage people to start reaching out to people over LinkedIn, getting feedback, as well as recruiters, and also, of course, applying online for jobs. I think people should do this earlier rather than later, so they get that feedback and also kind of help get over some of the imposter syndrome that often comes up when you're learning on your own or by yourself without a formal structure. And so this is, I hope this diagram makes sense to people, but it's really just about kind of making sure that you're getting out there, you're getting feedback, you're blending kind of learning and doing at the same time, and they're not kind of variegated and kind of very separate processes. It's really kind of a more holistic. The key thing here is that one of my philosophies and just things that I've uncovered is that the title data scientist is not a particularly good one. And I have links to some core answers I've done in the bottom left corner where you can actually kind of see my longer thoughts on this. But it's a very broad role, and it is sometimes difficult to actually to specialize as a data scientist. And if you can't specialize in some way, it is hard to move up in your career. It's hard to make career switches sometimes. And it's also a little bit of an identity crisis. And so I think that I put it in the middle in big red text. And there are, this is still probably the most common title, but I think even if that is the title that you have or the title that you're looking for, I would really think about where in this triangle you actually see yourselves and where do you actually want to be, because you can't be everything. You can't be the hardcore math person and the hardcore engineering person and the hardcore business person. It's simply not possible. And so you really have to think about what kind of area in this triangle that you want to be. And this triangle is not the only way to map out the different jobs that are out there. If you've gone online, if you've read these blog posts and books, there's tons of people who've tried to make Venn diagrams out of this, talking about skill overlaps, position overlaps, lots of infographics about this. So I'm not claiming that this is the only way to think about it, but I think this is a very useful one. And it's something that I'll kind of keep referring to in this presentation later. So it's a good guiding diagram. And so ultimately, this process should be very much informed by which switch you want to make. And later on, I'll talk about people who've made the switch in the context of this diagram and how they did that switch. But ultimately, you have to figure out where you are right now and where you kind of want to get to. And so I'll quickly go over some of the key ones. So business analysts, this is what sometimes people refer to as deck builders. They're making PowerPoint decks. They're making Excel documents. They're very focused on operational data and operational analytics. So they're really thinking about revenue, sales, marketing. They have a close heartbeat to the business, and they're really kind of focusing on how the rest of the business kind of impacts these important metrics. And they do work with a lot of numbers. They're kind of more higher level summary stats or percentages or kind of revenue numbers. They're not kind of usually doing a lot of in-depth, what I would consider more scientific exploration. And then as you kind of move over to the left, you have another amorphous title, which is data analyst, and I put this kind of conference interval if you want to think about it that way, because depending on the company, data analyst can mean very different things. Arguably, depending on the company, data analyst could literally be in any part of this triangle, because just like data scientists, many companies don't know how to properly frame a title, and they kind of use these catch-all terms. But generally, when I've seen it, this is how I would think about a data analyst. Is somewhere kind of between the modelers, people do the statistics, and the people doing thinking more about the business. So you may be, while a business analyst may be thinking at a high level about what promotion to run or which promos in the past have been successful and their impact on the business, a data analyst would be more closely working with the marketing person to actually help frame that promotion, perhaps help with some A/B tests, things like that. And so they would kind of bridge. They're usually the bridge between business problems and business goals, and kind of the data and some of the stats behind that actually link to that and power it. If you move over to the left, you see statistician. Traditionally, these are thought of, for a while, this is the only way that you had this title. Like, you were a data scientist. If you went and got a PhD in a quantitative field, you had experiments running rigorous A/B tests and kind of clinical or scientific experiments. And so you were kind of able to bring that experience with you to work on business problems. And so these people are kind of usually knee-deep working on optimization problems for big tech companies or insurance companies, finance, right? They're very, very focused on the numbers and statistical accuracy, very obsessed with modeling. And they're usually less technical. It's not always the case, but they usually use tools that are adopted more by academia. So MATLAB, sometimes R, rarely Python. And then as you kind of go up towards the top right, towards the middle rather, you can kind of get more and more technical. And instead, you end up being more like an engineer. So you're usually an engineer who's informed by data science thinking. And as you get closer to engineering, you really get at the heart of engineering for data science, which is these kind of large-scale distributed systems that big companies and even kind of medium-sized startups have to monitor. And so you're usually kind of less thinking about what business problems does it solve. You're really kind of focusing on supporting the modelers, supporting data analysts. The last interesting one is sales engineer and data consultant. So these two positions are also very interesting, and they're often natural ones for people to break into who come more from a business background or who are more interested in the business side of things. I spent a brief time doing a similar kind of role, and it's client facing. You spend a lot more time interpreting information. You're usually more technical than business analyst. And again, that depends a little bit on the role. So it's also an interesting place to think about. And the last one, obviously, is data scientist. It's just kind of a catch-all term. Depending on the company and the team that you're on, this could mean very different things. I would say data scientists in general is incredibly flexible. So they're good enough at the technical side, and the engineering side. They're good enough at the stats. They're good enough at thinking about business goals and working backwards from them. And so there are many people who have this title, and they usually still, if you really dive into the work they did, they would still lean more to the modeling side or the engineering side or the business side. So this is kind of just a overview of the landscape. So key principles, right? So this is kind of, here are the 4 things, and there's definitely more than these, but these are the 4 I'll cover in this talk. The 4 important ideas that I kind of encourage everyone to think about. And it provides a good framework for thinking about what to learn, what kinds of titles should you target and positions, and just in general kind of hopefully reduces this giant search space of like tools, like techniques, technologies, job titles, industries. It really kind of helps you focus and actually kind of make progress. So first one is career capital. So what is career capital? So career capital, it's from Cal Newport's book, who is a computer science professor at Georgetown. He has an excellent blog and a series of books, and they're really the only books, and his blog is the only real source that I recommend people read for career advice, because he's a computer scientist. So he's very kind of rational and numbers oriented and very kind of critical of more broader things that people use to describe their career, like passion or finding what you love. And he thinks those things are important, but those things are actually more developed as you get better at a skill. And he doesn't see them as things that you kind of independently figure out and just go and do. So I really like that focus, and it's also the great part about it is it's a book that literally anybody can apply to their own career, because it's not really focused on one career or another. And he actually interviews over 30 people from all kinds of different backgrounds and talks about how they've applied some of his framework essentially, and also how those stories informed the framework. So it's a great book, and it's a 3-hour read. It's actually harder to implement than to read. So career capital, what is it? It's essentially the biggest point in the book, which is that just like you have social capital or you have just standard monetary capital, career capital is basically your measure of the expertise, the skills, and the kind of depth that you have in a certain area or a set of areas. So a really simple example would be if you went and got a PhD in statistics, then you would perhaps have a lot of kind of deep understanding of statistics. And so then when you're thinking about positions, when you're thinking about where do I want to go, you want to find places and positions that really they really value that deep knowledge of stats, right? And when you think about, okay, well, there's usually not a one-to-one fit between maybe what you learn in school or on a job and where you want to go, then you have to think about how can I bridge that gap, right? If I'm really good at stats, what do I need to learn? What products do I need to do? Or what do I need to study to bridge the gap and tell the story for the positions that I'm targeting? And I'll talk more about that, and we'll come back to it a few times in this presentation. So some of the key level ideas here, auction versus winner-take-all markets. So he has 2 different ways of thinking about jobs in general. So he frames, so an auction market is basically a career market where you can, there's many different ways to acquire the same knowledge, and there's many different ways of demonstrating and having that value in the market. Whereas a winner-take-all one is basically one where there's a very specific skill, and it's really 95% of succeeding in that kind of role is really about just being really, really good at one thing. So a winner-take-all market would be some common examples are sports. For most, if you're targeting a specific position on a basketball team, you really are judged by like how effectively you are making shots or whatever is necessary for that position. Acting is a very similar one. Music can be one, depending on how you think about it. The best one is kind of script writing, so writing plays or writing for Hollywood. Really the most important thing is that one thing is people don't care how you look, they don't care how tall you are, they don't care how good you are at math, they don't care about all this, they really just want to have this deliverable of how good are the scripts that you're sending me, right? An auction market is very different. It's basically one where there are multiple things that you may have to master or think about, and there are multiple routes to get that same expertise. So I would argue most of technology is more like an auction market. There are software engineers who work in many industries, who have many different degrees or no degree, and who are still able to kind of get jobs that they find interesting. And there's basically not a very narrow definition, and there's many ways. And so the good thing is data science is very close to an auction market. It's probably the best example of an auction market because there's no degree really that guarantees you or that you have to do for data science. It's people have come from literally every background. And even at DataQuest, we've seen people come from all kinds of backgrounds and still get jobs in data science. That's the kind of classic definition of an auction market. Increase your capital store. So if you think about this triangle right here, think about which titles are you targeting and where do you feel weak in, and how do you increase your knowledge and skills in an area so you build a more comprehensive profile for that position. Here's another one which is perhaps less relevant but still interesting to think about, which is working backwards from a work lifestyle. So he has a good chapter there about people usually have different goals. So whether you want to there's some people who want to be a Fortune 500 CEO. They want a corporate jet. They want to work 100 hours a week, and they really want to kind of be in control of this large organization. And so they're excited about that lifestyle. For others, they want to help charities, and they want to maybe work 15 hours a week, or only half the time of the year, and do consulting, and they want more freedom. And so depending on, and of course, there's a lot in between as well. Most people fall in the middle, which is kind of working somewhere and then perhaps going to a bigger company or a smaller company afterwards, right? So most people fall in the middle, but thinking about that work lifestyle is very interesting because that could lead you to think about different kinds of projects you want to do. So if you're very focused on rising up the corporate ladder, the technical skills are probably less important. It's probably way more important to be very aligned to the business and really attuned to the goals of every business that you work at or start. And on the flip side, if you're doing consulting, it's probably more important to have a one or two specialities that you consult around, because it's hard to be a consultant in 10 or 20 different things. It's the best way to be a consultant is to have a niche skill and really kind of nail that. And so when you look at positions, and you think about like where, if I want this consulting lifestyle, if I want this flexibility, what position should I be targeting? Another one, which he indirectly alludes to, is minimum viable position. So when you're thinking about what career switch you want to make, or where in this triangle you want to move, it's really helpful to think about the MVP, minimum viable position. So if if you've just graduated college with a business degree, it's not that feasible to go and work on AI research at Google in a year, right? That's kind of a huge leap. You're kind of going from somewhere over here and kind of like going this way and going all the way over there, rather going this way. And that's a really big leap to make, and it's very difficult. And so this, again, is going back to my frustration with the data scientist title, because I think that title is too catch-all of a term, and too many things are associated with it. And I think what that leads to, and I've seen this firsthand, is people getting overwhelmed about what they feel like they need to learn. Career capital and minimum viable position helps you think about what kind of skills am I missing to make this next leap in the general direction that I want to go in. And then after you do that for a year or two or however long, you can reevaluate where you want to go. And also you'll have more experience at that company and doing data science in one of these positions. And so your interests may change. And so I think I really kind of encourage people to think about what is the minimum thing that they can do to break into the field if they're not in it, or if they want to make a career switch, similar idea. Last one, storytelling. So even if you believe in career capital, and if you believe in the expertise that you have and the one that you'd like to gain, if you can express that to a recruiter or in your interviews, then that's kind of doing yourself a disservice. And I've seen many brilliant people with graduate degrees, all kinds of really interesting projects, not be able to sell themselves. And I think that's really unfortunate, because if they really kind of are willing to learn that and practice that, then they could have a lot more success. So here's kind of a quick actually I talked a little bit about this, but I'll go over it real quick. So business analyst versus data analyst. And so a common thing people want to do is to move from business analyst to a data analyst role. That's one of the most common switches that I've seen. Business analysts have been exposed to data. They work with people, and they kind of constantly hear the importance of data science, and they want to make a switch to a data analyst, which is kind of that next minimum viable position. So usually they may have experience in a specific sector, let's say healthcare. They have little to no data analysis. They mostly live in Excel. They're doing the high-level summary stats percentages that I mentioned. They're mostly thinking about business problems, and mostly creating slide decks, distilling relevant data. Now with data analysts they're more technical. They're usually using SQL and Python. They usually can get the data themselves if they need to. They're maybe thinking more about the problems on their team. So if they're on the marketing team, how do we run better promotions? Really getting into the details. If they're on product, similar thing. And they usually, the result of their work may not be a slide deck or a high-level summary, but actually a kind of more of a report or a notebook that's living and can be modified, or even a dashboard sometimes, depending on the tool you use. And so I think the career capital framework helps you think about how can you make this transition successfully. And I think an interesting one here is really, filling in the technical details. If people don't know, if people feel like you mostly create slide decks your whole life, then when you're applying to jobs, you need to make sure your portfolio has things that are not slide decks, things that are closer to dashboards or advanced data reports. And the last one I think is very interesting that often people don't think about is sector. So if you've been a business analyst in healthcare, think about what advantage you can have. What informational asymmetry do you feel like you can take advantage of, right? So specifically when you're working on projects and you're trying to figure out how to transition to more of a technical role like a data analyst, target data analyst roles in healthcare, because your portfolio projects can be targeted and oriented more on healthcare. If you're kind of still at that healthcare job, the business analyst job, you can find other interesting data projects to get yourself involved with. And you may even find that there's an opening for data analysts within your own company. So there's sometimes a tendency to throw away everything you have and target some pie in the sky job listing that you've seen, or just kind of dream about a specific position that you would love to do. And I think career capital helps you think about why that's probably very difficult to do. And it's kind of more realistic and more productive, really, in my opinion, to make more of this this more direct switch. So the key principle here is deep work. So this book is also by Cal Newport. He's basically written a book. Every time he's kind of hit a roadblock in his life or thought about how do I succeed at this thing that he's doing in this phase of his life, he's written a book about it. And so he wrote one in high school, he wrote one in college, he wrote one at the end of his PhD program. And then as he was transitioning to becoming a professor, he was thinking about deep work as well and how to succeed. And so I think deep work is a very underrated skill, and right along that is deliberate practice. So deliberate practice is kind of this phrase that's come from performance psychology. There's a guy named Eric Anderson who came up with the 10,000 hours rule. And essentially deliberate practice comes down to really finding, really trying to understand what you want to learn and being very, very deliberate about making sure that you aren't fooling yourself and that you're really kind of forced to get in and deeply understand something. A quick example here is that people who in music and chess, which are the most commonly studied things for commonly studied areas for performance psychology, they're the people who succeed in those fields aren't just playing their favorite songs or just playing chess with friends or at tournaments. They're actually they're working with the coach, which is why coaches exist, and they work with the coach to really understand where they're weak and how do I focus on that and really practice that. And so he has a great story in Deep Work about a musician who he grew up with, who he's now kind of a somewhat well-known bluegrass singer, musician rather, and he literally spends 2 hours practicing 1 or 2 notes, just because that's the thing that is important to nail that piece. He didn't just play the song over and over again. He really slowed down and really focused on that one skill and really made sure he got it before he moved on. And then he sped it up. Right, so it's really about being deliberate. So how's that manifested for data science? I think the way to think about it is to think about structured projects for learning. So it's definitely great. I strongly encourage people to do portfolio projects around questions they have or things that they would like to solve, or just data on things that they find fun, like flight delays or alcohol or parties or kind of whatever topic people interest in. I think that is good, and that's a good curiosity to have. I'd also encourage people to think about projects that encourage you to go a lot deeper. So maybe you have to build a full data dashboard instead of just a Jupyter notebook or a SQL report, right? Maybe you actually, if you're have more of an engineering mindset, maybe you actually implement your own SQL database, a small version, because it forces you to really understand the technical details. And or perhaps kind of diving into one of your favorite tools like like an open source version of SQL or Pandas, like really diving into the code base as you're using those tools and understanding what is going on under the hood, right? And that's part of kind of re-implementing from the ground up and looking under the hood. If you're more stats and machine learning interested, then re-implementing papers and code and writing your own blog post, or even finding a new way, a new interesting mathematical property is a very good way to kind of really make sure that you understand something. I think this is super critical in data science. And I think this also cuts against the tendency and the kind of overwhelming set of techniques and tools that people feel like they have to learn. It's if you understand a few of the key machine learning algorithms, for example, or if you understand how relational data works, then just those two things alone, those two ideas are manifested in data science in many different ways. And if you deeply understand them, you can quickly pick up any tools. You can go from pandas, you can do SQL, you can switch flavors of SQL, you can move on to other kind of whatever futuristic tools that we'll use, because these key ideas you really deeply internalized. Another one here is systems and goals. And so the students I've seen on Dataquest and even other people that I've mentored really succeed. They have a good set of habits. So they spend some time learning every day, or they have specific time set aside every week that's non-negotiable. They treat it as a meeting. They treat it as an event that they have to go to, and it's on their calendar. If it's at work, people can't schedule time in that slot, and they really see it as I'm going to spend this much time every week or every day of really learning. And I think that's incredibly huge, because just like exercise, learning isn't something you have to do. You can definitely thrive and have a good life without doing a lot more learning once you have a job. But same with exercise. But if you do it, that gets you a huge advantage, and it helps you reach the goals. And then for getting a job, I mean, there's always going to be some amount that you have to fill in your knowledge gaps in. Another one is incremental improvements. So don't try to kind of boil the ocean. Really figure out a few. Right, going back to the original slide that I have about the life cycle. Really kind of do a project maybe in a week or two and try to get feedback. And whether that's from professionals, whether that's from friends, any kind of feedback is important, because there's many ways that feedback can come. They could be technical, it could be more mathematical, it could be around communication. And often underutilized or underappreciated part of data science is being able to communicate complicated ideas to people. So just because maybe your parents aren't data scientists, if you present a report to them and they can't understand it, or you can't explain to them, that's also a good opportunity for learning more about communication. The last one is type feedback loop. So always try to find a way to create a type feedback loop. So the project does not grow. And when you're doing things like networking, when you're doing things like interviewing, the tighter of a feedback loop you have, the better it is. I think the last key one is think scientifically. This is perhaps kind of a moot point, but still I think important to mention. It's absolutely critical to not get overwhelmed, to not chase trends, to not avoid thinking more deeply about what it is that you're doing, especially if you're learning part-time. If you're trying to make career switch part-time, there's a lot that you can learn, and it can be overwhelming. And being able to focus and really being deliberate about what you learn, where you spend your time and attention, is really important. So the first one is 5 whys. This is often used in kind of a product management or business context, but I think it's really useful anywhere. So when you read a headline, when you read a new announcement, or read about some new machine learning thing, the 5 whys it's basically about asking kind of 5 levels of questions. So is this true? Why is it true? And then kind of keep going down, why is that true? And really going deep into the key idea or insight that is relatable to you, and then kind of cascading that up scientifically. So what else? So using data to improve a personal process. So if you go back to this slide, forming good habits. People even I've seen many smart data scientists who have advanced degrees in stats fail to use data and a little bit of data science thinking in their own life, whether that's trying to lose weight, whether that's trying to learn for an hour a day. Data science isn't something you do at a job. It's really a way of life. It's really a way of thinking. And so, I actually have spreadsheets myself of my own goals for learning and where I'd like to spend my time. If I'm not hitting them, I know at the end of the week that I'm not hitting them. So, and this also goes for recruiting. A lot of times people have a tendency to apply for a bunch of random jobs and just drop their resume everywhere. But if you instead think about applying for jobs as a scientific experiment where you apply to a few, you're kind of recording the key properties of that, and you're also measuring the success rate, you can reflect on that every day or every week and think about how you would improve that. And yeah, this is something that I've seen many people not do. And the last one's whenever possible, remove luck. This is kind of a catch-all thing phrase, but luck is fundamentally, depending on who you ask, really, but it's commonly defined as kind of the unknown. It's this unknown variable in your equation, or this unknown force that's going to have some positive or negative impact in some process or some activity in your life. And more knowledge and more understanding and more research is how you reduce the role of luck, right? So when you're applying for a job online, and you got the job, and when you say, "Oh, I was so lucky, I got the job," that really means that you're admitting that that luck played a huge role, because you actually don't have a good idea as to why you got the role. People who work hard and have a very clear idea about the roles they're targeting, they don't really believe in luck all that much, because they kind of really did the research and they really tried to understand, how do I remove chance from this process? How do I really kind of engineer my way and research my way into succeeding here? And if they can't, they also know why. Usually they failed. So I think that's, removing luck and removing that uncertainty as much as possible from the learning process, as well as the application process, the whole life cycle, really. It helps with confidence, and it really forces you to think more critically about why something did not go the way you wanted it to go. Challenges. So I'll kind of go through some of the challenges that I've seen students face. One is understanding what to learn. And I think this is very closely tied to career capital. So what are you good at right now, and how can you actually demonstrate it? If you can't, then it's perhaps worth thinking about diving more deeply into it. On the flip side, what are you weak at? So how do you actually improve using deliberate practice? And related to both of these is research. So research the positions and industries that you're interested in, and think about your MVP, minimum viable position. When you think about that, you should have a set of gaps. You should kind of be able to say, here's the positions I'm targeting. I've done a lot of research. I've read about kind of the companies I'd like to work at. I like their work culture. What gaps am I missing in my skill set? And in the things that I have, can a recruiter or a hiring manager kind of really understand the skills I have right now? And then what do I need to fill in gap-wise? So that could be math, that could be doing technical projects, that could be giving a presentation. So there's many different ways you can build these skills, but it's really important to think about what kind of capital you actually have, what kind of knowledge you actually have, and then how to augment that with projects. Another huge challenge is obviously learning technical data science skills. So I talked a little bit about this, but it's good to reiterate. Deliberate practice is really the key here. So if you're learning a new tool like Python or Pandas or SQL, learn the fundamentals and use it to solve an interesting data problem, right? So find something interesting. Like don't just learn the tool in the abstract, but actually apply it to a real problem, or kind of a real business problem of some kind. If you're at an existing job, right? Math, learn the fundamentals. So really learn the key ideas in calculus, linear algebra, if you want to be more of a math-oriented data scientist, and re-implement it, like write a blog post and re-implement it in the new tool that you just learned, perhaps, or some new language that you're also trying to learn, and just find a way to re-explain it. One thing that, when I used to be an author at Dataquest and manage the content team, that was something that people really enjoyed doing, is that even if people thought they understood a set of concepts really well, being forced to write educational content around it really helped them solidify their own understanding. I think this is basically another way of doing a similar thing. And of course, the last one, communication. So I encourage everybody who's trying to make a career switch to have a blog. The point of a blog is not to be famous or to have people, tweet the link out or something. I would argue those are slightly more shallow reasons to do it. I think the real reason is, even if it's just going to be 5 people or your friends or family who are going to read that blog, it's some kind of accountability, and it's some kind of public-facing thing where it forces you to kind of think about how you communicate. Often when you're learning and you're getting feedback, if you're not able to kind of express the ideas that you have or explain to others, then that makes it hard to really succeed in data science, because at the end of the day, most of data science is powering some business decision or some decision in research. It's all about understanding a system and trying to make better decisions. So if you can't give a good recommendation, if you can't explain the data or the analysis you did, then it's often not utilized, and it's kind of a wasted effort. And I also have a blog, a link to our blog post. On our Dataquest blog, we have tons of blog posts about career advice and learning. So this is one I linked to here about getting started with learning some of these skills. Another huge one, which I'm sure many people have tackled with, is imposter syndrome. This is somewhat linked to just the vastness of the title and the space, and every day there's some cool new technology or algorithm that says it's going to change the world, and that kind of further feeds the imposter syndrome. There's also a sense that to be a data scientist or to work in data science, you need to have a master's or a PhD or 10 years of experience. And I think ultimately the best way to overcome this is to have this incremental process where you're getting feedback, right? So going back to one of the original slides I had, you don't want to be learning in a cave, because if you aren't getting the right feedback and you aren't getting the right exposure. So you really want to learn a little, build a little, get feedback, and I think that's super critical. And as you get feedback and as you reflect, you'll realize even if you're doing a month of learning, where you get to in a month will surprise you if you really reflect. Because if you ask yourself where I was a month ago, and where, how surprised, you'd be very surprised to know how far you got, just because a month ago you didn't even know you could do this. So being able to reflect and getting external feedback is really important. The other thing is that experienced data professionals have it too. The ironic thing is that for many people, imposter syndrome actually gets worse the further into their career that they go. So they feel more like I'm like a senior data scientist, or I'm like the chief data scientist. I don't know anything. Like I don't know how I got this position. I don't know how long I'll last. And so for many people, ironically, it actually gets worse over time, because they start to realize there's even more things that they have to learn. And so I think networking and getting feedback from others, that's one of the first things I'll tell you, is that, look, like, this product looks good, and I know you're just starting out, but just keep going, because this is something everyone faces, including myself. And then I have a blog post here at the bottom called I think it's titled "How to Overcome Imposter Syndrome for Good." So if people are interested in reading more about that, they can click the link at the bottom. Another challenge: how do you build a compelling portfolio and resume, right? And I think the key thing here is telling a clear story in your resume. And I'll talk about some examples in a few minutes. Use portfolio projects to really align with either specific learning goals. So this is the deliberate practice bit I mentioned earlier. Building your own database system, or building your own file system, or building a data visualization charting library in JavaScript, right? These are technical examples that I'm giving, but this could be applied to non-technical things as well. Blog posts would be the best one. And so those are specific things that you really want to show that, hey, I really wanted to master this skill. I really want to understand the weeds. So I literally implemented it myself, or re-implementing a mathematical paper, for example. And then the other portfolio projects that are good align with your story and your career interests. So going back to the healthcare business analyst person, you could imagine someone who has a resume just dripping with their passion for healthcare, right? Like they're a business analyst in healthcare. They saw some of the problems. They can tell the story about how they really wanted to get close to the data because they were noticing inefficiencies, or they were noticing something that was off that they wanted to use data to explore. And then they built portfolio projects that used open healthcare data, or perhaps data in their own company if they had an opportunity to do so. So either of those projects can be really good. The projects I don't recommend generally people doing, except purely for self-learning and self-interest, is the Twitter data projects, the Kaggle projects. And the reason is that I think they're fine for learning and they're good for your own kind of internal experience. But I think the problem with the Twitter data projects, for example, is they're too generic. Everyone does them, and so when you put them on a resume, and your resume is mostly full of projects that are generic, then I have not seen that work out all that well. Just because they're too generic and it's not unique, and you can't really spend an hour talking about why this project was super interesting, usually, and it's just too common. And when I've done recruiting for data science in the past, my initial red flags go off when I see people using the same generic projects or using projects only from school, right? So like data science really is, you need that curiosity to succeed as a data scientist. And so if someone's resume, someone's projects are full of things other people told them to do, that indicates that perhaps there's a curiosity that's missing there. And yeah, so that's an example of that. And lastly, this is something that's often misunderstood or not thought about, but I think it's critical to really think deeply about the recruiter experience. So put yourself in the shoes of a recruiter. The most common things that will come to mind, and if you talk to most recruiters or engage with them, you'll learn is that recruiters get a lot of applications. They get a lot, and I'm using the word recruiter very generally. It could be a hiring manager, it could be a team lead, but they get a lot of applications. We're a small team at Dataquest, about 20 people, and even for a single position, we get hundreds of applications. For more popular ones, we get thousands, right? So, and it's usually just one person doing it kind of part-time. So for most recruiters, there's an industry average quote about this. Depending on which one you read, most recruiters spend 15 seconds per resume, some spend 30. If you apply to a place like Google or Facebook, there's definitely, usually resumes are screened by automated software first before they even get to a human eyes, because they're getting hundreds of thousands of applications a week. And so with that in mind, you really have to think about your resume and portfolio as the things that will tell your story, show that you're competent, and then get you past the front door, right? It's not an opportunity for you it's not the best place to talk about everything you've done. So with that in mind, I always recommend resumes be only one page, no matter how much experience you have. If you can't explain it in one page, that indicates often a failure of communication. There are exceptions for people who've come from academia and have CVs, but usually companies have a separate section for resume, which is CV. And I would kind of still encourage them to only have a one-page resume. And the last thing I recommend people doing is actually when you redesign your resume, really think about if someone spends 15 and 30 seconds, what are they going to take away? Most recruiters are looking for reasons to keep your resume in the running, not reject you. Right? So they're looking for the presence of awesomeness, not the presence of negativity or something. They're really looking for things that will help you stand out. And so don't make your name too big, right? Don't make your email like obnoxiously large font, right? When you think about what are you going to bold and what's going to be in capital letters, those are going to be the things that stick and linger with the recruiter. And so with that in mind, when you redesign a resume and when you apply some basic design principles, I actually recommend people literally give their resume to 5 random people. It can be friends, family, whoever, and then take the physical resume, print it out, give it to them, take it away from them after 30 seconds, and ask them, what did you remember from a resume? That is the best gut check way to make sure that what you wanted them to remember was actually remembered. And we have a 4-part series about building a portfolio on our blog with this bit.ly link at the bottom if you're interested in learning more about that. Cool. So some success stories. So these are all from students that we've mentored or helped indirectly. So Christian, he was a marketing consultant and a manager. He worked in marketing, had his own company for a little while doing marketing consulting. He worked as marketing manager before that. And he had some experience with a little bit of analytics, kind of Google Analytics stuff, the standard marketing stuff. And then he went to an MBA program. Right after he graduated his MBA program, he spent a few months learning on Dataquest, really getting into technical details, learning SQL, filling in. He had a lot of the business context, but he was missing a lot of the technical details. So going back to the original triangle, he was kind of really close to that business analyst in the bottom right corner. And I'll show that slide again in the next slide. And so now after going to Dataquest, after filling in the gaps he had, he landed a job as an analyst at Blizzard, right? So this goes a little bit back to the title thing. He used a lot of data in his job, but he has his generic title, which is analyst. At Blizzard, which is a huge gaming company, he works on the Battle.net platform as an internal consultant, internal data consultant. So specifically, he frames business questions and he finds data-driven solutions and strategies. And he works with data scientists, project managers, and other analysts, right? So going back to the career capital thing, going back to minimum viable position, he really figured out, how do I take the capital that I have already, which is in marketing, which is in business problems, which is in using kind of analytics data to think about business problems, and how do I combine that with all the things that I learned in my MBA program, as well as on my own on Dataquest and kind of his own projects, right? And so This is kind of a good merging of stuff he's learned with his own background, and he's he's been very happy in that position. The advice he gives is he advises other students to be consistent and to find a project that will really keep them motivated. Going back to the habits, going back to deliberate practice, do 30 minutes every day and you'll get a lot further, and the concepts will stay fresh. And so this is kind of the lessons here is he told a really great story, right? So he had a marketing background, he got an MBA, he filled in his spare time, he really filled in the technical details, and Blizzard was happy to hire him to be kind of a technical business problem solver. And I think that he considers himself a data consultant, so someone who's technical enough to get data out to answer questions, but also very business savvy. So he made that switch from business analyst, some kind of in that marketing business corner, to being more in the middle right here, a data consultant. Use your existing career capital. I think I mentioned this already, but he didn't throw away. He didn't aim for a generic data science role or a highly technical one. He really wanted to bring all the expertise he already had with business problems and combine that with his technical skills that he's acquired. Communicate about data and technical skills effectively. I think this is, I mentioned this before, but I think it's super critical to be able to do that. Create a habit of learning and practicing every day. This goes to his quote about spending 30 minutes every day learning. Second success story, Harry Robinson. He used to be a geophysicist. He worked doing analytics for a geophysics company for a few years. The roadblocks he faced when he was thinking about transitioning was most companies did not understand how his work in geophysics really translated to their business problems, because it was kind of more scientific, more about the environment, and I think it was in oil and gas specifically. And they didn't, like a marketing or a finance firm didn't really understand why that was relevant, right? So what he did was he went through Dataquest and he built a portfolio of projects. We have some on our site, and he's also adapted them and made his own. He built a portfolio that really communicated both his prior work better, as well as the new projects he did that were a little bit more relatable and understandable to people in marketing and finance and other areas. He's specifically interested in businessy kind of positions. So after Dataquest, he worked as a data strategist at Shared Creative, which is a marketing agency. And he switched. He's now a senior analyst at Philips, which is obviously a technology company. And so he's kind of a lot closer to the data analyst and data science realm. He's a lot more technical now than he used to be. And he was always technical, but I think he had a hard time perhaps communicating that in his resume and portfolio. So the advice he gives is don't try and rush through learning. It's more valuable to take your time and know a few things really well. I think that's kind of a pretty self-explanatory. The third success story is Vignesh. He lives in Singapore. He used to be a science teacher. He had a degree in chemo informatics. And he liked teaching, but he really wanted to get closer to data science. He used Dataquest to learn all the tools. We teach the full PyData stack, Python, Pandas, SQL, other tools like Spark. So he liked learning tools all in one place. And he also spent time really deeply understanding the key algorithms. When we teach an algorithm like neural networks or k-means, we always focus on kind of in the lens of deliberate practice of actually building up and implementing the algorithm from scratch, even though in the real world, you'll probably use a library. After that, he interviewed Accenture, and he was actually literally asked about k-means, and he was able to explain it really well. And he started as a business intelligence analyst. He competed in an internal data science competition, and he networked with the data science team, and he was promoted data scientist about a year or so later. And so he's a great example of someone who kind of kept on learning. He understood the key concepts really deeply. So he made the switch kind of from this BI analyst, data analyst to a data scientist. He's having a good time there. And he also did a good job leveraging their previous work experience. So when they were interviewing for data science position, they talked a lot about the projects that they did before kind of interviewing for the position. And that wraps up my presentation. So now there's a bunch of time for questions. I know I've scheduled availability for people who do one-on-ones. I unfortunately can't meet with everyone just because those are 30-minute slots. But I have put my email at the bottom if people have follow-up questions, if they have any thoughts, or if they want some quick feedback on something on the resume or something like that. I can try to accommodate some of those things. So one, I see one from Mario Anthony. So can I build my own portfolio with modified examples from online courses? Absolutely, and that's actually what I strongly encourage. Going back to what I said earlier about if you have a generic project, it's really hard to stand out. So you want a portfolio project that either goes deeply technical into something in a way that will encourage you to learn and also indicate to others that you're serious about gaining mastery in that skill, or aligns with your story. So a good example here is actually a quick anecdote is I had a friend who now works at Reddit as a data analyst, data scientist, I think actually, and he had a marketing background. He was targeting San Francisco data companies, and so the story he wanted to tell was just about his kind of passion for being in SF and his background in data science, and also the ability for him to build full stack applications. So he didn't just do analyses, he actually built mini websites. And so he spent 4 months building a fog prediction map, which is basically a website which showed where the fog would be in San Francisco any given day. And that project is very funny in many ways because the fog is kind of this funny part of the culture in San Francisco. It's just kind of everywhere. People don't really know when it's going to show up or not. It literally has a name called Carl the Fog. And so that project was a very interesting one, and at least 3 different recruiters found it very interesting. And they were also able to click through and actually see the fog. So it was kind of something that any recruiter that wasn't technical could understand. And it clearly showed like his interest in San Francisco, where he was living. It was really unique. Like most people don't see those kinds of projects, like a really unique personal thing that he wanted to build. And 4, it was an actual website. It was living. It wasn't a notebook that was hard to understand. And so that, I think that's a great example of something where you can use online courses like Dataquest or others, use them for inspiration, but you really want to take them in your own direction. And ultimately, for this guy, he in his interview, they spent half the time talking about that project. And so if he wasn't really passionate, if he wasn't really curious about it, people would quickly realize that this is just something he did for fun or just to get a job instead of something that he deeply wanted to understand. Kobos, hi Srini, when you're talking about the transition between a business analyst and data analyst, is there any point in the middle? Do you have an opinion on tools like Microsoft Power BI? Yeah, that's a complicated question. I think ultimately, like the triangle that I put, it is a little bit generic. There are hundreds, maybe thousands of little different titles, and different companies use different titles. It's really hard to kind of comment on the entire landscape. It varies a lot by industry as well. But I think that you really have to focus more on the key actual idea. So what is the key difference between a business analyst and data analyst? And I think it really is being a lot closer to the decision maker. So you're not just summarizing like, oh, here's what the supply chain looks like, or here's what our promo did. You're actually influencing how that promotion was run or how the supply chain is run. And you're just more technical. You're not relying on someone to send you a spreadsheet that you're going to combine. You can actually go in and investigate the data and poke around yourself. So if your company is using Microsoft BI tools and it's connected in the right way, then perhaps that's okay. But I think ultimately a data analyst is very flexible. If the data is in SQL, they have to be able to kind of go in and do it. If they have to do some aggregation that's not working well in SQL, they may pull it out into a CSV and do it in Python. So I think a data analyst has to be flexible. And that's what I would focus more on is what superpowers do you really have, not what title do you have, because ultimately some may give you a data scientist title, and there are data scientists who live in Excel, right? And if they only focus on the title, then I think that they're selling themselves short, and they're not encouraging themselves to learn more and fill in their own gaps. So that's what I would say. I would focus more on what you feel like superpowers you have, and think about like what can I not do, and how is that limiting you? So if you're like, this data lives over here, and I can only use this Microsoft BI tool, I can only use Excel, then that kind of discomfort should push you to learn more and see if you can dive in and understand the necessary skills. While having the expertise in front-end development, which data science area would you recommend the best fit, creating the most interesting outcome and front-end skills? I think the most natural fit there is data visualization. I think it's hands down the most obvious fit. There are positions like data visualization engineer. There are Netflix and Castlight Help. I've literally seen postings from them about that specific title. So I think those are the best titles. If you're coming from a front-end background, is that ultimately focus more on the presentation side. So like how does these charts look to the outside world? So I would look at data-driven blogs or data journalist positions potentially if you also want to learn more data science. And so like 538, right, The Guardian, all these New York Times all have data journalists positions, and they also hire data visualization staff. I would look at data visualization engineer positions at Castlight Health or Netflix. So I would really focus more on data visualization. I would, in the beginning, right, going back to minimum viable position, I would probably focus a little bit less on things like machine learning or even Python. I would really focus on the presentation and design side of data. Wow, that's kind of my opinion of it, though. Thank you for sharing your presentation, insightful. Thanks so much. Networking, thank you very much. What else? From someone who's currently studying math theory and statistics for undergrad, how can I develop my skills and make small steps towards becoming a data scientist? I think this answering that question is basically my entire, I would argue, is my entire presentation. I mean, I really think it's about where do you want to go? So what do you have to offer, right? So what, have you worked in a specific sector? Even if it's not in data science, have you done something in that sector where you can be like, okay, I want to go deeper, and it's probably easier to get a data job in that sector than a different one. Can you do your own projects? I mean, when you're an undergrad, I think that's the best time to explore. So do internships, volunteer, nonprofit, and really look for data opportunities in any form. Right, my first data science internship was actually a data entry internship, and then a month in, I started automating the work. And then my boss was an electrical engineer by background, so he encouraged that. And so I ended up, most people who interned there did data entry internships. I kind of saw an opportunity to automate some of my work and make it better for the team and save time. And so then they had me do programming and more technical data science stuff. So any opportunity to work with data, even if it's unpaid, I would jump on it for undergrad, because in undergrad, you have the most freedom and flexibility to explore things. So I would really explore. I think I would probably focus a little bit less on the title that you're targeting. If you're just starting out, I would really just explore a lot. Like, do you enjoy programming more? Do you enjoy stats more? You can't, in a job, you won't be doing all of them. That's the reality, for better or for worse. And so I would just think about like what you really enjoy doing, and even the work lifestyle. Do you want to be a consultant one day, living on a beach, working 20 hours a week? Do you want to be a high-powered CEO? Do you want to be a team lead of data science where you're managing people? Do you want to be a research scientist doing fundamental research? So I would think about and explore those. Would you be able to share a sample data resume? I don't have one off the top of my head. I was thinking about including it, but the talk was going along. If you search for data scientist resume, let me see if I can pull up how to write the perfect data science resume. There's a bunch on Google, tips on building, one second, let me see. I can't find a specific one, but I'll paste one from our blog at least, that I think could be helpful. I'll Google around, really. What do you think of the remote job market for data scientists? I think it's not bad. So interesting, Dataquest is actually fully remote. We're completely distributed. That was kind of a cultural decision of ours, though. Most companies are not like us. I think that I think the jobs that are the most remote are probably closest to data consultants, because there's more flexibility for traveling around. If you really want a job that's remote, I know remote is not the same thing as travel, but if you want something that's remote, I would get used to kind of being a data consultant, someone who's coming in and helping them solve problems. For other tips for remote is, it's usually it's hard to get a remote job right out of college or right as your beginning job, because you usually don't have that level of, usually don't have that enough career capital where people trust you and think you can work independently. So going back to the work lifestyle bit, if your goal is to work remotely, which I've been doing for 3 years actually, and I enjoy it, I highly recommend everyone think about it. I would really think about building some skills first, getting a brand name job or getting something, a few years of deep experience, and then looking at remote jobs, because remote jobs are usually leaning more towards intermediate and senior, because training people often remotely is very difficult. So they usually don't have a lot of junior positions. I'd also encourage you to check out this site right here that I'm pasting, which is weworkremotely.com, which is job positions that are only remote. Can you estimate how many data scientists there are in total? That seems like an interview question that Google would ask, like how many ping pong balls would fit in a 747. I don't really know. I think it depends again on what you mean by data scientist. If you mean the person who's very generic, doing a mix of everything, maybe 5,000, 10,000, it's hard to say. Maybe 20,000, I don't really know. If you're talking about people who are using data science in some non-trivial way, hundreds of thousands. Yeah, I think part of the kind of mission of Dataquest is that every job is becoming a data science job. Whether like it's not for marketing, it's not like Mad Men anymore. You're not sitting in a room and just kind of talking about ads and very generically about demographics. It's really a data-driven thing, right? And sales is very data-driven now. So I think many aspects, in a good way, are becoming a lot more data-informed. And so I think that soon doctors will need to, if we have more software and more automated analysis of things like MRI images, then doctors will have to be more focused on interpreting data than actually like interpreting an MRI scan, for example. So I think that the number of people that need to understand data science, at least a little bit, is increasing very quickly. And I wouldn't be surprised if in a few years, millions of people are will need some kind of data science and some kind of data science thinking. And the last thing I'll say there is that there are a lot of people who are doing something like data science and they don't know it. If you're using Excel and you're working with numbers and you're modeling a system, on some level that is data science. And Excel is the most popular programming tool for data science, and that's often underappreciated. Which data science area would be good fit for my current work experience, which is UI test automation development? It's a good question. My mom actually works vaguely in that same area. I think in terms of data science, there's a few ways you could probably think about it. You could think about, what are people doing for a lot of because data science is often implemented in software of some kind, scripts, database systems, Hadoop, whatever it is. It's still software, which means it still has all the same problems of standard software development, which means it still needs to be QA'd, it still needs integration tests, and those have actually been less developed. And so I would actually encourage you to think about what are people doing for what is QA, what is automation, what does integration testing look like for data science or for machine learning? How do you actually do QA for a machine learning algorithm, right? It's very different. It's not about test cases. It's really more about how well does this model generalize? How much bias is there, right? So I think I would think more about how you would support data science and data engineers in their QA process. That's what I would think. It's not quite the UI test automation, but it is. That's a story I would try to tell. When you're thinking about how do I transition, I would think about broadly about owning automation and testing, and then getting kind of closer to data science. Excellent talk, well organized. Thank you. Thanks. Having close to 10 years of experience in application development from P&C Insurance, I'm now able to graduate in Master's in Business Analytics. How difficult is it to convince recruiters having a lot of experience outside of data science? What roles are best suited for me, say DS consulting or pure technical roles in DS? I'm not sure. So application development, I'm guessing you mean software development, so like web development or enterprise application development. How difficult is it to convince recruiters having a lot of experience outside of data science? I would try to find a way to align them. So if you're working in P&C Insurance, the story you want to tell is, I've done a lot of app development in P&C Insurance. I really understand the field, and I learned all this data science, and so now I want to go back to insurance. Now, maybe you think I'm tired of insurance, I want to get out of it, but going back to the philosophy of minimum viable position, that's probably the easiest way for you to get some hands-on experience with data science for a few years, and then you can think about kind of dropping more of the insurance stuff and finding other areas to go into. So with regards to consulting or technical roles, I think it really depends. It depends what you want to do. If you're doing consulting, you have to think about the trajectory there. I'd encourage you, everyone here should be on LinkedIn Premium Trial, like reach out to people, alumni of universities, people who work at job titles that you would like to work at, and reach out for advice. It's shockingly easier. It's shockingly easy to get that kind of insight and advice by just talking to people. And also reflecting on yourself, like what do you want to do? Consulting usually means more traveling. I'm not sure if maybe you're interested in doing that, maybe you're not. More technical roles. Again, there's pros and cons there. So it's really up to you. I originally studied software engineering, but currently would like to transition to data science. For me, data science is just a phase to get through to business and finance analytics. Would that be a logical trajectory? I mean, I don't know why you can't get there directly. I mean, I would consider that, right? Like, so if you worked, for example, you could work as a software engineer at a financial analytics company. I think everyone here should learn some data science. I think that it's important to understand stats. It's important to understand data visualization and how to communicate results. I mean, you can do those things and not feel like I can now call myself a data scientist or have to identify as that person. If you strip away the identity part of it and just think about, this is a way of thinking about the world, just like reading and writing is not about becoming a professional writer. It's really just about being able to make decisions, use information in a different way, et cetera, et cetera. With that in mind, I would definitely encourage you to learn data science, but I don't think you have to go and work as a data analyst and a data scientist to then go and work in finance. One possible interesting thing for you to think about is what's interesting about the technical challenges in finance and analytics. Right? So much of finance is capturing data. So if you work at a company like Bloomberg, or if you work at Jefferies, some of these places that are doing large data capture, large data modeling, you don't have to deeply understand the math and algorithms. You can if you want, but you can really position on how do I build distributed systems? How do I build systems that are really reliable and have high uptime that will let analysts and other people take advantage of the data. So you can kind of geek out about just large scale data infrastructure. And that will let you kind of skip some of the need to go learn a bunch of math. And you can still do that if you like, but I don't think it's a necessity. Would you suggest getting certified in product management for that position? I'm not sure what position you're talking about, but I hear certificates mean nothing. So even here, right? So even here, one of my philosophies one of the principles I had was think scientifically. So is there a way for you to verify that? So can you, this may sound silly, but you can try applying for some positions with the certificate on it versus without the certificate and see what happens. Or alternatively, maybe a better one is you can actually show your resume to recruiters, right? Like use LinkedIn, reach out to some recruiters and ask them if this is something in your industry that they care about. It's really hard to generalize. In some industries like healthcare, I know people that work in healthcare, they actually like seeing that PMP certificate. In software and tech, they usually care less. In fact, companies like Facebook and Google are well known for even hiring college dropouts. So that seems to indicate to me that certificates are not as important there. So I would think about the industry you're in. I would research on LinkedIn, see like of the people who are doing the position you want, how are they presenting their profile? Are they attaching PMP at the end? Do they have those certificates on their LinkedIn? If so, then it may be something you have to do. So I don't think there's a universal answer here. Most of the questions here don't have universal answer. I think that's the fundamental thing I want to get across. It really is dependent on where you are, location-wise, industry-wise, the positions you're targeting, your own background. So yeah. I work as a social network analyst. So this is from Siddharth. I worked as a social network analyst for 2 years, pursuing data analyst courses at Udacity to further advance my skills. Any suggestion on how I can get more of it? What practice should I do to attract recruiters? I don't know what a social network analyst quite is. I'm guessing it's an analyst for a social networking company like Facebook or LinkedIn. What I would do, I would figure out what story you want to tell, right? So if you have this experience working in a social network, do projects that are more in network theory, that more in graph theory, that maybe visualize networks in a unique way, there's Yelp and Facebook often release public data sets for analyses. Do projects around those. So really, if you have this background in social networking, really embrace that, and that's probably the easiest way to get notices. You have this, your resume will be dripping of your passion and interest for social networking because you work there, you leveled up your skills, and now you're kind of wanting to go back, right? So, and also I would think about applying to the same company that you worked before and see if you can get a higher position. That's something I would consider. And yeah, I would really think about if that's, the easiest way to get a position is to reduce uncertainty, to really think about what are all the reasons someone would reject me for and squash them in some way. See if and also focus. So if you're focusing on social networking companies or companies that need to work with that kind of data, then your product should be there as much as possible. So, and there's a lot of great open data sets out there right now in every domain. I think there's lots of good opportunities. I am a computer science master's student and I'll be looking for a job in USA soon. I don't have any experience. Is it necessary to have work experience in such fields of data scientists or data analytics? It really depends what you want to do. Computer science is very broad. You could be a game programmer, you could be a web developer, you could be a QA analyst, you could be a project manager. A computer science degree is a great degree to have, and it's very flexible. So you don't need to know data science unless you're targeting those positions. I would say that data science, unlike engineering, does require an extra level of curiosity And there's so many skills that you really have to kind of, and there's not a lot of great ways to learn in school. Whereas in programming, you actually can become pretty good at programming just by doing a computer science degree. So there's a pretty natural route to go into programming and engineering. So I think what I would think about is, do you have that data curiosity? Do you go around the world and think, oh, these traffic lights are so annoying, they're unoptimized. How would you build a model to do it better? Do you find data sets online, or do you find things about statistics like population stats and census data, and you're excited about analyzing them and understanding them better? If you don't have that, I think it is trickier to get a job. I think you're probably better off just trying to find something in software engineering, because there's a lot more positions, a lot more companies need them. Almost every single big company needs software engineers. And they need lots of them, but they need less designers, they need less product managers, they need less data scientists. They just need a lot more engineers, because if you're building software, then you'll be the one building the software. So is there opportunities for those in college, senior, to work part-time remotely after internship? Yeah, I think so. I mean, I had an opportunity to do so in my first internship, basically continue after the summer finished. That really depends on your rapport and your relationship with your manager, and if that company allows it. Remote is harder, but even then, right? Again, going back to removing luck. So how do you remove luck from this equation? I think the best way is, when you were doing the internship, really wow them to the point where they're like, oh, we don't want to lose it. Even this person's an intern, we really want to keep working with them, because they were just so productive, and they went above and beyond, and they really helped our team out a lot. And so even though we usually don't take people remotely, we usually don't take part-time interns, we love working with this person so much that we'd like to keep them on. That's how I would think about it. Besides that, I would also look for just opportunities online. There are many nonprofits. I would look at data science volunteering. That's a big thing now. There's a few nonprofits and hackathons and stuff like that, which is all about helping nonprofits that usually don't have the ability to hire data scientists or engineers. So that's also a good way to get experience. Usually unpaid, but when you're in college, I think learning is the most important focus. Cool. What would you say about data science and its application security? Based on the market and other side concrete on IBM, awesome live session. Thank you. What would you say about it? I mean, I think it's interesting. People have been using data and security for a long time. I think it's going to be more prevalent. Ultimately, a lot of the cybersecurity issues people have are often human errors. It's not like technical errors, right? So I think there's opportunities to use data. There's a whole movement of InfoSec, and I think it's called ML, SEC, just kind of like trying to use machine learning. I think it's been a dream. It's been a dream for a while, which is like, oh, you just have the software, and it just like every time someone tries to do something, it tries to automatically identify if this is an intruder or not. I think it's hard. I think the hardest part with security, if you're talking about machine learning specifically, which I'm assuming you are, although that may be putting words in your mouth. If you're talking about machine learning and that dream of a system being able to detect if someone's a hacker or not, or something, or an intruder, I think the hardest part is it's really hard to use machine learning for rare events. So rare events with big costs are really difficult, right? So that's why, for example, we're really bad at predicting earthquakes. They're rare, the data is very poor, and it's just rare. We don't have good techniques for understanding rare events. And so I think the hardest part about security is how do you focus on problems that can be detected using data science that are more common, or things like maybe you prevent DDoS attack or something. So I think there are interesting opportunities. It's not something I actively came up with. I'd encourage you to research and kind of learn more yourself. But I think, I think ultimately data science is going to be used everywhere, right? Like anywhere, it's very broad. Even as simple as collecting the number of people that visit your website and then using that to improve something in your business, right? Like even as simple as that, it's definitely going to be used anywhere that software that people interact with software, if it isn't already. So I just finished a master's program, and everything on portfolio, school projects, and open source work. I try and work on projects every single day, but my resume still doesn't have software engineer or data scientist as previous experience. How do you think people like me should try to go into the field? That's a great question. First, I would think about any formal work experience at all. See if there's a way you can bring that. So even if it was something completely unrelated, if it was in the same sector, at least, could you at least tell some story there? The other thing to think about is internships. Internships are a great way. Even though you finish the master's program, usually if you're within 6 months, companies will take you for internships. Two, I would try to research avenues you think are more accessible. So I would say that like software internet companies are usually more friendly to beginners. I would try to do a lot of research. I would spend a whole weekend researching on LinkedIn and Indeed and really doing some analyses on of the people with the titles I'm interested in, or of the listings rather with these titles, which one seems like they have less requirements, right? So this is kind of a mini data science project in its own right. You can imagine a spreadsheet where you're understanding the different roles, positions, how big the companies are, how friendly they are to junior, how many junior positions they have, right? That's something I would think about, is really trying to figure out what maybe sector or title that you can focus more on, or a few, and then build projects around that. And so in some areas it's harder. In finance and healthcare, there is less data, and that can be harder. But in like software or something more web-based, there's a lot of data out there. So I would think about what projects you can do and how you can align your stories. If you pick one or two sectors, your projects should be deep projects there. I mentioned my San Francisco friend who he didn't have any sector. He was just like, I just want a job in San Francisco in data science. And so his project was actually about San Francisco. So to summarize, I would think about internships. I would do a lot of research to figure out which positions you feel like are actually accessible. And I would figure out what based on that, I would use that to understand which sectors or which areas or titles you want to make projects look really like a deep project, something you spend a month or two on, something very unique, not just like I downloaded this data, I counted the unique values in each column, here's the result, right? Like really something kind of driven by that curiosity and that interest to learn more. And then networking, going to meetups. Meetups are usually free in any city in the US. I'm not sure if you're based in the US or not, but even most global cities have them. They usually have free food and drinks, and you get to meet people. So I think that's also a good way for you to kind of research and understand more. How do you suggest preparing for DS technical interviews? I feel as if I'm very dependent on looking up the appropriate. I think there's probably two things here. One is to answer the first part, Glassdoor.com. Go to Facebook, go to Google, go to all the companies that hire lots of data scientists, and really try and see what questions you can answer and not, and try to get to the core insight as to try to peel back the layers and understand what is the deeper thing I need to understand here. So not just, oh, well, I don't understand the difference between L1 and L2 regularization. And so you may go to Wikipedia, you may read about it and be really like, oh, cool, I know now. But the deeper thing is kind of more about machine learning. Like, why do we have to do this thing called regularization? Like, why does it happen? How do you deal with it across different algorithms? So you want this kind of more general thing. So I would use Glassdoor as a way to understand the areas that you feel like you're weak in. And also there'll be there's tons of interview questions. I would avoid really getting overwhelmed and really focus on the key things. So not trying to be able to, it's okay if you can't answer some of them. That's kind of a reality. But if you have the key knowledge there, I think that would help. The second one is deliberate practice. So if you feel weak in A/B testing or some algorithm or a tool, figure out what kind of project you can do that will force you to really go deep. So if you don't understand why maybe your pandas code or Python code is slow, can you re-implement that yourself? And then try to go through and compare that with their source code and see, most code is open source nowadays. So you can actually compare and kind of dive into. It may be hard, if you've never got into a code base, it may be difficult, but you can at least set up a structured project with these goals where you make a little bit of progress every day. For algorithms, I think you just have to implement it yourself. Like go on a whiteboard or a piece of paper and be like, K-means algorithm. Try to describe it, see and then try for an hour. If you can't do it, look at the solution, and then try to reframe it yourself, and then practice that until you get it. Really, it's kind of boring and repetitive, but that's really what it takes to understand these ideas really well. What specific DS concepts or statistical concepts do you need to know to ace a DS interview? What kind of questions employers tend to ask the most? I think my previous answer mostly covers this. It really depends on the position, but I think if you're looking for some general advice, Glassdoor, to deliberate practice on the key things you're targeting. Read the job title that you're looking at and see where in that triangle in that slide that I had, is it close to stats? Is it close to engineering? Is it close to business? What are the steps to go for data analytics? How do I start preparing it sequentially? I'd recommend going. I'd recommend my slides. That's a long question to answer, but I would think about where you are and where you want to get and how to close that gap. That's probably the shortest answer I can give there. If someone comes from math and stats background, what skills would most be valuable to learn to get into data science field? a similar thing. Like, where do you want to go? What positions are you targeting? What industries are you targeting? Really try to focus as much as possible. And then think about what gaps you need. If you have a math background already, focus on the math and the stats that is used in industry. So which kinds of algorithms are used? They're more on the applied side, some machine learning, if that's interesting to you. And then tools. I think that then if you already have a math background, being really good at SQL, really good at Python are two things you can do. It's becoming easier to go into a lot of ML fields than before. Udacity has, etc. Do you think that taking those broad and different degrees shows the person is not focused? I think it depends. I mean, it depends on the story you're telling. I think ultimately with regards to NLP, deep learning, reinforcement learning, those are maybe 1% of data science, literally, in terms of job titles, in terms of where people are spending money. Like those kinds of things get 95% of the media attention and blog post attention, and they're cool and they're interesting, and they feed into our science fiction fantasies. But most of data science is, we're trying to understand why this process is taking so long, or why is this promo not working. Like, most data science is more mundane, and it's really about solving a business problem. And so I think those things are interesting, and I encourage people to learn them. But unless you're working on a very specific application, so if you're doing deep learning for medical imaging and you really have a background in healthcare and you have some programming experience, usually they want to see graduate degrees, right? Stuff like that. Reinforcement learning is used a little bit in robotics. Those things are still pretty new, and it's really hard to use. The tools are really complicated. Most companies don't have server infrastructure to run like thousands of GPUs and do live deep learning. So I would say that those things are still pretty fringe. I think they're interesting. I keep up, with it, some of it myself, but most of data science is really about queries, it's visualization, it's statistics, it's these tried and true things that are going to be around forever, really. So that would be my kind of counterpoint. And yeah, I think broad and different, the more focused you can be, the better. I figure out the things you want to be broad in. Like, it may be good to be broad in math if you're focusing less on stats, but really be deep in the technical side or the communication side or the business side. I got one more minute. For someone with 3 years employment gap and zero experience, what would you suggest they do besides working on DS projects? Network. So you're looking for, going back to removing luck from the equation, reducing uncertainty. You want people to vouch for you. So if people see a random resume and they see a gap, some people are like, oh, what was that person doing? So one, I would try to take that question out of their head. Talk about the stuff you worked on during that period, right? So I've seen literally people put like maternity leave, 2 years off, here's what I did. That sounds silly, but that's a good way of getting around that. Two, networking is a great way as well, because that gets you in front of people, and when people see your passion and they hear about the projects you worked on, then they can put in a strong referral if they think you're interesting, and that will overcome some of the limitations that you may have. But there's a cloud option to use cloud computing as well as in-home GPUs. Yeah, that's true. I think the other hard part is that it's very expensive. Like, running those GPUs is very expensive. They still solve a very narrow class of problems. And yeah, if you want to talk more about this, you can shoot me an email. But it looks like the recording stops in 5, 4, 3. So it was good. Great. Thanks, everybody.